Last two parent functions, exponential and logarithmic functions. For our exponential, remember the points that you were supposed to memorize are -1, 1/2, 0, 1, 1, 2, and 2, 4. If I plotted these, -1, 1/2, 0, 1, 1, 2, 2, 4. Remember, here we have another asymptote. The asymptote here is just a horizontal asymptote at the line y equals 0. So my graph is never going to cross that line. It's also going to get exponentially steeper. So it's very steep right there. And then it comes this way. Domain for this one, all real numbers. We're going infinitely to the left and infinitely to the right. But your range, y is only greater than 0. It can't equal 0 because that's our asymptote. Again, if you prefer the interval, it's 0 to infinity. For our logarithmic function, remember that these are inverses of each other. So our points for this one are just the opposite. 1/2, -1, 1, 0, 2, 1, 4, 2. Again, this one has an asymptote. If this one's at y equals 0, this one's going to be at x equals 0. We have a vertical line here that your graph is never going to cross. I could plot my points. 1/2, -1, 1, 0, 2, 1, 4, 2. Creates this reflected graph. Again, be sure your line doesn't cross your asymptote. Again, if I just switched my points, I kind of just switched my domain and range too. Domain is x is greater than 0. Again, not equal to because that's your asymptote. If you prefer the interval 0 to infinity with the parentheses, range is all real numbers. Okay. Figuring out the type of transformations is very similar to all the other equations. A 2 in front, which isn't going to happen very often, but does sometimes, is going to be a stretch. Plus 3. Notice that it's a tiny 3. That's considered inside with that exponent. That's a left 3. Minus 3 inside, again, tiny 3. Right 3. Plus 1 outside, up 1. Negative, reflect. Minus 5 outside, down 5. Same thing for the logarithmic, just like all the other equations. Minus 1 is inside, that's going to be right 1. Minus 1 outside, down 1. Negative in front, reflect. Plus 1 inside, left 1. Plus 1 outside, up 1. 2 in front, stretch. Let's actually graph a few of these. So starting here with number 14, the 2 in front, remember that's your stretch. Plus 1 outside, up 1. So before I do too much else, I'm going to go ahead and write down my table of values over here really small because I don't have tons of room. -1, 0, 1, and 2, 1/2, 1, 2, and 4. Remember the stretch is going to multiply all of your y values by 2, making my new points 1, 2, 4, and 8. After that, I'm going to identify where my asymptote is. I've moved up 1, and then I haven't done anything else. And remember with the exponential, it's a horizontal asymptote. So I'm going to go ahead and draw this little dotted line here to help me remember. After that, your 0, 0 point, your new 0, 0 is still right here. All I've done is move 0, 0 up 1. From there, I can plot my new points. It's going to be -1, 1 because it's stretched, 0, 2 because of the stretch again, 1, 4, and 2, 8. This one's going to be even steeper than normal, and then continue on infinitely. Domain for this graph, still all real numbers. Range, again, if I had identified this is a horizontal asymptote, that's at y equals 0, so my range is going to be y is greater than, I'm sorry, it's not at 0. We moved it, it's usually at 0, but we've moved it up 1. So now it's at y equals 1, so our range is going to be y is greater than 1. Looking at our next function, a couple more transformations on this one. Reflect left 3, down 5. So again, I'm going to start by drawing my asymptote. Usually it's at 0, 0, but I'm moving left 3, 1, 2, 3, and down 5. 1, 2, 3, 4, 5. Put a dot. This creates my horizontal asymptote across here. That line is at my horizontal is at y equals -5. From there, I can use my normal table of values, except remember that they've been reflected. So normally, if this is 0, 0, we use the point -1, 1/2, but it's reflected, so it'll be on the other side of that line. Then it's 0, 1, 1, 2, 2, 4. Domain, still all real numbers. Range, y is less than, because it's been reflected, -5. Switching to our log function. Negative in front is still a reflect. -1 inside is still going to be right 1, plus 2, up 2. So again, I'm going to start by drawing my asymptote here. Right 1 and up 2. Remember, this one has a vertical asymptote, so I'm going to draw a vertical line through there. My vertical asymptote is at the point x equals 1. From there, I can plot my normal points. If you remember what they are, I'll save them for the next one. But it's usually at 1/2. Again, here's your new 0, 0. So it's 1/2 -1, but we've reflected it, so it's going to be up here. Then it's 1, 0, which in this case reflected. When I reflect a 0, it's still a 0. Then we have the point 2, 1, but again reflected. Then the point 4, 2, that's been reflected. Here's our transformed logarithmic equation. Domain for this one, again, x is greater than 1. Range, all real numbers. One more function. 2 in front is a stretch, plus 3 is an up 3. So this time I'm going to go ahead and write down that table of values to help us out. So usually it's at 1/2, 1, 2, 4. This is -1, 0, 1, and 2. But these are all doubled, so -2, 0, 2, and 4. Doubling those values. Again, first thing I want to do is find my new 0, 0. If I move it up 3, 1, 2, 3, put a dot there, that's where my vertical asymptote is, which is still going to be at x equals 0. From there, I can plot my new points. Here's my new 0, 0. Usually I'm at 1/2, -1. This time I'm at 1/2, -2. Then 1, 0, 2, 2, 4, 4. One, 2, 3, 4. 1, 2, 3, 4. Sorry. Here's my new transformed equation. Domain is x is still greater than 0, range, all real numbers. Flipping to the back, writing the equation from them telling you how to transform it. Not too bad. Start with a log equation. Left 3, up 2. Y equals log. You have to have the little 2 there because that's telling you part of the type of shape your log is going to be. That helps determine your table of values. But inside the parentheses, left 3 is going to be an x plus 3. Close the parentheses. Up 2 is a plus 2. Again, starting with a log function, reflect it. Stretch it by a factor of 2, right 4, and down 3. So y equals -2 for the reflection and the stretch. Log, tiny 2, because that's part of the equation. Inside parentheses, because it has a right or a left, we're going to go -4. Outside, -3 for the down. Lots going on in that equation. Starting with an exponential, reflect it and go right 6. Y equals negative for the reflection. 2, because again, that's part of your equation here. Since I'm going right 6, I need the 6 to be inside with the x, means it needs to be tiny, tiny, tiny. So x minus 6. Be sure, again, that I can tell the difference between a tiny 6 and a big minus 6, because that makes a difference when you graph. Are you going right 6 or are you going down 6? Be sure I can tell the difference. Exponential, left 1, down 7, and shrink it. Y equals, I need my shrink first, the 2, and sometimes you can put it in parentheses. Sometimes that looks a little better. Let me look back and see what they did on the other page. Yeah, we better put the 2 in parentheses. So I'm going to put parentheses here so I can tell what's happening there. 2, I need a little plus 1 for the left one. So x plus 1 tiny. Outside, we can put our -7 for the down 7. One more equation, log, reflect it, and stretch it. Stretch it by a factor of 5. So y equals, I need the reflection and the stretch, log little 2 of x. I don't need anything else because I'm not going left or right, so I don't have to have the parentheses. Sometimes I think it's kind of tricky to tell from these graphs. First of all, you have to know what type of function these are. So you need to identify first where those asymptotes are. So here is my asymptote here. I think it's easier to find the flattest part of the line and identify that first. If I have a vertical asymptote, then that tells me I have a vertical asymptote at x equals 0. That tells me that this is a log function. Looking at this next one, I have a horizontal asymptote at y equals -3. Tells me I have an exponential. Looking at this one, here's the flat part right here. Horizontal asymptote at y equals 1, 2, 3, 4, 5. Tells me I have an exponential again. Flat part here. That's a vertical asymptote at x equals -1, 2, 3, 4, 1, 2, 3, 4, 5, 6. These lines all start to run together. Tells me I have a log function. So after you identify that, you kind of need to find your new 0, 0, and sometimes this can be tricky. So you have to remember where that first point is. So they're not including the half points on here, or maybe they are. Yeah, they're not including the half points. They're just starting at the 1 point. So our first point here is usually at 1, 0. So 1, 0 is right here. That tells me 0, 0 is right there. That can help me find my transformation. So this graph has moved up 3, and it's been reflected. So that can help me write my equation. Now I know y is going to equal, reflect tells me negative. I need the log with the little 2, because that's the type of graph it is. It hasn't moved left or right at all, so I don't need parentheses. And then a plus 3 on the outside for up 3. Looking at the next one, exponential function. Again, your first point is usually 0, 1. So that's where this is. That puts 0, 0 right here. So I've moved to the right 1, 2, 3. And down 1, 2, 3. So kind of tricky to find that new 0, 0 point. From there, I can write my equation. It hasn't been reflected or stretched. So I need a y equals 2 to the x, tiny plus 3 for the right 3, big minus 3 for the down 3. Looking at the next one. Again, that first point is right here. This is another exponential. That's at the point 1 at 0, 1, which has been reflected. Here's the point 0, 0. So this tells me I've moved left 2 and up 1, 2, 3, 4, 5. From there, I can write my equation. Y equals negative 2 to the x plus 2, big plus 5. Last one here. Again, this first point is usually at the point 1, 0. So 0, 0 is right there. I've moved left 1, 2, 3, 4, 5, 6, 7. Here you can also use the asymptote to help you with that. And down 2. So my equation, y equals, hasn't been reflected, log little 2 in parentheses, x plus 7, big minus 2.